Let's get started. I am so excited to be not bringing you the 9th edition of this year's community meeting, the September edition. And I'm super excited to introduce Maggie, who, if you've not known by now, you will know her all the time. She just joined Acryl Data to lead community product management for DataHub. And she's already made some big changes. I'm super excited to see all the Slack cleanup that has happened, and really excited to welcome her and have her lead this meeting. So go ahead, Maggie.
Hello, everybody. It's wonderful to be here. I'm going to share my screen. And we can see this?
Yep.
All right. Hi, I'm Maggie. I am the new DataHub Community Product Manager. I've been in the data industry for about 12 years at this point. So I have a background in analytics, data warehousing, BI, product management, team building, a bunch of things. I've been in the DataHub community for about over a year now. So I actually led the product rollout of DataHub at my prior company. So super familiar with the tool and also very passionate about it. This is my email address. I will let you know I am not very good at email. So if you'd like to get in touch with me, please Slack me. And these are my two dogs, Tucker and Marlo. You'll get very familiar with them in the chatter channel. But yeah, most of all, I'm just super excited to be here and really just understand what the needs of the community are and how we can really make DataHub a huge success. So we have a lot to cover today. We're going to do some project updates from Shirshanka. We'll have a demo of faceted search from Gabe. And then we'll take it back to Shirshanka and Surya to talk through stateful ingestion. We have Iker joining us to give us a case study of how DataHub's been rolled out at Adevinta. We'll do some improvements to our Looker connector, and then a sneak peek of foreign key support. So plenty to cover. Let's dig right in. Shirshanka, I'll kick it over to you.
Yeah, so as usual, I did a quick git commit log, group by, all of that stuff. And turns out we've maintained our 100-ish commit per month rate since the last town hall. Again, strong diversity in the contributor base. We've got 20 contributors from 12 different companies. And release 0815 is around the corner. So we're on 14 right now. We'll probably be rolling out 15 next week. Biggest highlights over the past month that we've accomplished. One that you wouldn't have actually noticed at all, which is time series metadata actually got better in the last month. We rolled out support for aggregations. And so our usage stats endpoint, which was a very specific endpoint that we had created for supporting usage stats queries on DataHub, has now been replaced with a completely generic time series backend. And so that's really exciting because it allows us to roll out time series capabilities for all kinds of metadata. Second thing that you probably noticed is fine-grained access control was launched right after the last town hall. And we've been getting feedback and improving it as we go. So love that people are starting to try it out and looking forward to more feedback and making it better. Third thing, business glossary, we shared it last time, rolled out the basic YAML-based source right after the demo. And we are starting to add some features into the UI to allow you to edit your business glossary or add terms to data sets as well. Three big highlights, product improvements, integrations, and developer experience. So next slide. Product improvements, business glossary. When we first rolled it out, Saxo Bank did most of the work actually on the UI front. So thanks a lot for that, and the modeling side as well. One of the feedback we heard from the community was, hey, this is great, but we really want to be able to add terms right in the UI, just like we can do it with tags. Same for terms at the column level. So we added those capabilities. And so now you can do that. We also split up. People were getting a bit confused about tags and terms together. Like, are these social things? Are these governed things? Not quite sure. So we split them out into two separate areas. And so, we'll keep evolving as we get feedback. Another thing, top right corner, you'll see policies showing up, and that's basically, John's baby. He's driving access control out throughout the whole stack. So please give him feedback, and we're excited to see what you can do with it. Yeah. So integrations, three big areas of improvement. The big news is Amazon Redshift. We finally have usage source for Redshift. So Chinmay just added that earlier this week. So now you're able to connect to your Redshift warehouse and pull out usage stats. And we'll talk about what that means just a bit later. You can get recent queries as well as top users and things like that. We're covering Looker improvements and changes later, so I'll not get into that. But big changes to the Looker connector have happened, and some small improvements in the glue connector. It wasn't pulling out partition keys in the past. So thanks, Asim, for adding that contribution in. And finally, developer experience. Dexter wasn't able to demo last time at the town hall, but he did a separate video that we put up on the YouTube channel. Highly recommend you watch it. You can now monitor DataHub, front end, back end, everything through Prometheus. And there's some example Grafana dashboards, so you can actually monitor the health of your DataHub cluster. It's pretty nice. We're starting to roll it out on our SaaS deployment as well. The other few things that were just annoyances that we solved were, when the metadata service would start, you would always find kind of an empty store problem. Data platform logos wouldn't be rendered and things like that. So we added support to Bootstrap common data platforms on startup. So that way, when you finally ingest your metadata in, the logos are right there for you. The DataHub CLI, which you probably are very familiar with, now supports environment variables for unattended runs. So you don't have to sit at your terminal and confirm that you really want this particular GMS host to be used and things like that. So thanks to Asim for contributing those features. And last but not the least, we are finally very proud to announce the official release of our GraphQL API. And I'll hand it over to John to cover that.
Hey guys, yeah, I just wanted to give a quick update on the state of DataHub APIs overall, including the GraphQL API. There's been a lot of questions recently about, what is the primary programmatic API that we should be using to build on top of DataHub. And I think as of this week, we are kind of making GraphQL that API. As part of that, we've done a lot of work recently to improve the API. If you wouldn't mind, Maggie, clicking enter, I think we should. Yeah, so we have a few major recent developments on the API. We actually extracted it from the front-end server, which is now becoming more of a pure proxy web server, which will just serve the React bundle and then proxy to the metadata service. So we've extracted from the front-end service and moved that back to the metadata service. So now the GraphQL API is exposed at that backend layer where you're probably used to querying our legacy REST API. We've refactored it for consistency and cleanliness. The last 9 months, we've built a lot of features. So we built them very quickly. We had to do a quick pass over that. So we've deprecated a bunch of fields that we're using in the UI and made it more easy for programmatic consumption. The third thing is we added some rich documentation to the API. As part of this, we have auto-generated docs that will now show up on the DataHub Project.io website that'll show all of the GraphQL queries and mutations and types in our schema, hopefully making it really easy for you to get up and running against that GraphQL API pretty quickly. There's a lot more we want to do here. So I'll just quickly mention a few points on the vision. We really want GraphQL to be the primary programmatic interface to the metadata graph for various reasons. One of them being that GraphQL actually serves the use case of querying the graph really well, because you can get multiple entities and traverse the graph's edges in one query, as opposed to having to make multiple queries that you would have to do in a traditional REST API. We want to have robust authentication and authorization sitting at the GraphQL layer itself inside of the metadata service for both service use cases as well as the users coming from the UI. So this GraphQL API will serve as a general purpose API that's shared between both the React UI as well as programmatic use cases. And then finally, we want to start to build out that ecosystem of client SDKs that are built on top of the GraphQL API. So you can imagine maybe a Python SDK repository and a Go SDK and a Node SDK that makes it really, really easy to really interact with that DataHub metadata graph from wherever you are. So I think we're really, really excited about this, and we're really interested in feedback as well as contribution from the community to help make this vision a reality. There's a lot of work left to do, a lot of additional use cases that we can build into that API. So really looking for support from the community on this. You can just hit enter again, Maggie, and I think there's maybe one last thing. Yeah, so to learn more, check out the new GraphQL reference guide on the DataHub Project IO website. We've got an overview of GraphQL, of our endpoint, and then a reference, an auto-generated reference for the entire schema. So again, really excited about this. With that, I will hand it back to Shirshanka.
Cool. All right, and so one of the things we love doing, this is my favorite part, is recognizing all of the people who are actually making this project a success and this community a success. It's actually quite a few people. So I just want everyone to notice how, we started out with maybe recognizing 3 or 4 people, and then 6 or 7 people, and look at the number of people we've gotten in our community that are actually contributing in different ways. Abu, Asim, Claudio, Enrico, Frederick, all of you have been adding in very interesting and important features to and improving the code as you go. And on the community side, we've continued to see a lot of engagement, both from people who are starting to adopt and asking interesting questions, people who are asking directional questions like Alice and Jim and Martin, and then also people who are actually helping out individuals who are having problems like, Excel, Asim Bansal. There are a few of these folks, Frederick, who are really showing up as community leaders and really helping folks out in their DataHub adventures. So thanks a lot for all of the support, and we really love the kind of energy we're seeing in the community, and it's only going to get better.
All right, Gabe, I'm going to kick it over to you, and let's look into faceted search.
All right. So one thing that we want to demo for you today is an improvement that we've made to DataHub's search abilities. And so I'm going to talk through the improvements that we've made, go a little bit into the architecture of how this was built, and then also at the end, I'm going to ask for some feedback from the community to hear about how you feel about the direction of this feature. And we'd love to get input from you to help guide us in how we improve search in the future. So the intention here is to try to condense search into a more unified experience and help users of DataHub get to the information that they need in as few clicks and as little work as possible. So what I've done here is entered a search query for the phrase customer. And previously, in the old iteration of DataHub search, you would have seen multiple different modules, each with its own entity type. So some data sets that relate to this, some charts that relate to this, the glossary terms that relate to this, and so forth, in their own modules. And if you wanted to go and explore more, you would have to click one of those entities and dive into it. What we've done here is take all the results across the different entity types and blend them together so that the top ranked results from each entity type appear. We also are taking the filters from each entity type and blending them together so that if, for example, certain charts and data sets came from the same platform, as if you were to have some Looker charts and Looker views, selecting this Looker platform would filter just for entities across that platform for all different entity types. If I wanted to search for a single entity type, I can go to select this entity type filter, and then I see just the data set entities. And by clicking on a platform, I can filter down more and just see data set entities that relate to Looker. If there are tags or terms or other filters that are shared across these entities, they will also appear on the left-hand bar. And as new filters are added, they will dynamically insert themselves into the bar. So no matter what you search for, relevant filters and the relevant entities are going to appear in those search results. Let's see. So now I'm just going to talk through briefly the changes in the architecture that were able to support this feature. So previously, we had siloed search results. So each entity type would be searched independently, and the search results and filters would be brought back to the user independently. So a user would issue a search, and we would search data sets, charts, flows, etc. And those entity types would then give their own distinct responses. The filters for data sets, the filters for charts, and the filters for pipelines. What we've done here is put a layer in between that will aggregate the results together, rank them amongst each other, and then bring a combined search results and combined search filters back to the user. So the user issues a query to DataHub. DataHub then aggregates the search results and search filters together, handles pagination, and ranks these filters based on a custom filter ranking that you can provide. DataHub provides a default filter ranking, but you can also choose which filters are important to you and your users and rank those top. Then it returns this consolidated condensed result back to users so that they can go and filter as they wish and choose the filters that are important to them. So next, we want to take things back to you, the core users of DataHub, and help us understand better how this combined search result can suit your needs. So we're going to be posting a poll in the UI channel. I think Maggie just submitted it. And what we want to understand from you is how you use DataHub search and what you would expect from DataHub search. So please go to DataHub UI channel and tell us, when you enter a search term, are you usually trying to search across entity types? Or do you usually hope to search within a single entity? And we'll use this information to help steer the direction of this aggregated search and the development of search going forward. Feel free to vote and definitely give us your opinion. But also, if you want to throw unstructured comments in, we support that as well. You have just general thoughts about search, feel free to comment on that poll and give us more feedback. We really look forward to help building search with the rest of the community. And I think with that, I can give it back to Maggie.
Awesome. Thank you, Gabe. And yeah, I just posted that in the UI channel. We're already seeing some votes coming in, very exciting. This is also just to kind of give you all a sense of what's to come in the community. I'm going to be kind of shipping out more kind of binary questions like this to you folks, just to get a sense of like how people are using the product, what can be improved. So this is just, one of many ways that we'll be collecting feedback from the community so we can inform product strategy there. Next up, we have stateful ingestion. So let me reshare this. And I will kick it over to Shirshanka and Surya.
All right. Hello, everyone. One of the things that we've done recently and are about to roll out in the next week or so is support for stateful ingestion. And it really improves our ability to not unnecessarily ingest old stuff again and again. And it improves the capabilities of new ingestion connectors to essentially only pull relevant information every time they run. So let's get into it. The next slide. So let's start with an example of a connector that we already have. It's called the Snowflake usage source. And let's look at how it works today. The Snowflake usage source starts up, and it's got in its configuration a variable called start time. And that start time can be specified in your configuration. So you can say start time is yesterday, or start time is day before yesterday. And depending on what you specify, the Snowflake usage connector says, okay, I'm going to start from this time and pull all usage logs from this start time up to a granularity, and the default granularity is 1 day. So essentially what the Snowflake usage connector is doing, every time it starts up, it pulls a window of data from the source, and that window is defined by the start time parameter. Now the start time can be specified in config, or if you don't specify it, the default source will just default it to now -1 day. So essentially it'll pull data for the previous day. Once it does all of that, it does aggregations in memory and then pushes a grouped usage stats grouped by data set and bucketed by this day granularity into DataHub. And that powers a bunch of features. If you go to the DataHub demo, you'll see monthly queries, you'll see top users, you'll also see column level stats and recent queries. All of that information is coming in from this usage source. And there are other usage sources like the BigQuery usage source, and now we have the Redshift usage source that are basically built the same way. So what's the problem? Next slide. First, the start time needs to be set as configurations, which makes it kind of interesting. Like, what do you set it to? Do you set it to today? Do you set it to yesterday? You basically have to set it using kind of your scheduler. So people have to use something like Airflow to really ensure that this runs every day and does not rerun twice the same day. So if you rerun today's job twice, the ingestion connector is stateless, and it just says, okay, I guess I'll pull data for today again. And this is not just a problem for the usage source. Pretty much every single source today is memoryless, which means it starts up and crawls the whole world and ingests metadata. So we wanted to facilitate sources to remember where they last left off, to allow for incremental ingestion so that we can reduce load on source systems and only produce relevant changes. Of course, when sources are pushing metadata out, this is all trivial because you're right in the context of actually making a change, so you can push metadata out when it changes. But for sources that are crawled, you actually need state to be able to ingest only the things that have changed. We also want these sources to be really simple self-healing cron jobs. You should be able to just run them, and they should be just able to figure out where they last left off and only pull the deltas. So how did we do it? Well, we thought about where we could store this state. So next slide. What were the requirements? Well, first we need temporal storage. So we need state to remember across time. And second, we want to be able to query that state to get the last successful run for a particular window of time. And of course, there are a few options for storing this state. You could either store it in your local file system, or you could store it in S3 or some other blob store, or you could store it in a DB, or you could store it in DataHub. And we were like, that's interesting. Maybe we can actually use DataHub as a state store for ingestion. And let's look at what that looks like. So what we ended up building is just leveraging the same time series metadata support that we added to DataHub to actually store state about metadata ingestion runs. If that's not meta enough for you, I don't know what is. So here's an example of how the Snowflake usage ingestion system changes once we add this capability. The first thing it does when it starts up is gets the last successful run state from DataHub. And DataHub internally has temporal state for all of the previous runs. Once it figures out the start time based on the last successful run state, it then issues the query to Snowflake, gets the deltas, does the same thing, groups usage stats, sends it over to DataHub. But in addition to all the metadata it produces, it also produces another piece of metadata, which is the ingestion run state. And that includes things like the run ID, the pipeline ID, the status, how long it took, other metrics, as well as the start time and the granularity. So that's basically the window. And each of these individual ingestion run events are really getting logged in DataHub on a timeline, which allows the usage connector the next time it runs to find out the last successful run and carry off from there. So that's in a nutshell what we've done, and it's working out quite well. Next slide. Surya is going to do a quick demo for you here. And just before he gets started, I want to give you an example of what we will be demoing. So today is September 24th in UTC time. And we wanted to show you what it would look like if ingestion was run 2 days ago and then rerun and then we move time forward to now, and then run ingestion again. So we want to basically show how ingestion runs would progress over time using a connector that, from a configuration perspective, is completely stateless. Over to you, Surya.
Okay. Sharing my screen. So for this demo, we have done something very interesting. So we have set up basically a Docker that can fake time with a library. So if you want to see what it looks like, so before we do the ingestion 2 days ago, so if I just ask like this, what's the date? It says today is September 22nd. So if I ask -3, what is it? It's 21st. So it's actually changing system time basically. So now let's go ahead and do an ingestion. So that's 2 days ago. Okay, so from Snowflake. So this is now going to complain about some clock skew. So, but that's okay. Still go ahead and finish it. Okay, started. This is complaining that it has detected clock skew. Potential clock here, right here. Okay. Now it's ingesting basically these records. So we have 48 work units produced. So now if I try to rerun basically for the same day again, so it shouldn't allow us to basically do it. It should produce 0 work units. Okay, done. So it has remembered what it did before for this day. Now we can actually.
So yeah, it might be a good idea to just look at that recipe quickly, the usage.yaml.
Yeah. So okay, the only thing basically from here that will survive is this. So the only additional basically piece of information this suite needs is basically where the GMS server is. So that's where time stats live in order to query these aggregations or like even push. So this is the endpoint we need. So the other configuration is going to go away. So yeah, so this is what it is. One thing that's interesting for you to notice is that like there is no time specified anywhere here. So now if we basically go back to the demo and run for today, you will notice that it will run for today basically. So it will do ingestion again of this records. So now let's get rid of this altogether. So, and this is now if I show you what current time looks like. So without this, date is basically today. So we are actually kicking off the ingestion for today. So which means it's supposed to basically fetch all the data for yesterday, all of yesterday. So okay, so here we go. So it's now, if you notice, this is the entire data basically from the start of yesterday. So 23rd. So and we again got 48 records. Now if we try to basically rerun the same thing, it shouldn't allow us to, it shouldn't produce any records. So done. There is nothing. Back to you, Shirshanka.
So yeah, maybe you want to use the, so this is pretty cool, but what is even cooler, I think, is what you see in the UI after you run.
Ah, okay. Where is the UI? I didn't expect you to ask for this. So let me pull DataHub.
So any questions so far?
Okay. Back here. Okay. So let's go see pipelines. So DataHub ingest. There's a pipeline here. So
Right. So what is interesting, I think, is that even the DataHub ingestion itself will produce a pipeline instance, which will allow us then to look at the ingestion process itself as a pipeline that runs and produces metadata. So now you'll be able to actually not only look at your data pipelines and your data sets and the lineage across all of them, but also your metadata pipelines, and make sure that they are running on time and that they are actually running successfully. So it allows us to use DataHub itself as an observability platform for metadata ingestion. Cool. So Maggie, I think we can go back to the slide deck. So this will get rolled out to all the usage sources, so Snowflake, BigQuery, and Redshift. Another thing that we want to roll it out to is the dataset profiling sources. These tend to be our most expensive profiling sources, and we want to start doing incremental profiling as well. And also start converting other sources, such as our SQL sources that are ingesting schemas, our Looker sources, to be stateful and only perform incremental pulls. This will reduce your API builds as well as reduce the time that it takes for these sources to run. So that's all coming soon.
Awesome. Thank you, guys. Also, shout out to Surya for running a live demo. Those are always very fun to watch.
And
All right,
changing time.
And changing time. We time traveled today, folks. It's pretty amazing. All right, we are going to move into our community demo from Iker. So I will hand it over to you, sir. He's joining us from Barcelona and on a bank holiday, I should mention. So thank you for putting in the work, even when you should be on vacation.
No worries about that. Can you see my screen? Can you hear me well?
Yes and yes.
Perfect. So I prepared some how to say corporate slides, but because it's Friday afternoon for me, then it's a little bit of fun moment. And after this, I probably will have beer and not coffee. Sorry for that. For the rest, you need to wait a couple of hours in the West Coast for that to happen. So first of all, my name is Iker, like email, not like iPhone. So it's Iker. I'm father of twins. I was a data engineer in the past, then I was an enabler, and now I'm a product lead at Adevinta. So now I don't know how to code or how to change time in Docker anymore. Sorry about that. Forgot all of this. What is this Adevinta anyway? Wait. So Adevinta is a marketplaces specialist. So we have many marketplaces around the globe, around the world. And we have different verticals, different digital brands. And we try to create perfect matches on the world's most trusted marketplaces. This is the fancy title we use for Adevinta. So that's what we try to do. If you need a car, go to Adevinta's marketplaces and you will find your car, your house, your job, a new pair of sneakers, whatever you want. Right? Many brands around the world, many marketplaces, different teams, different offices. And since last summer, or since this summer, actually, we bought eBay Classifieds Group. I see, Surya, you have an eBay t-shirt, but this is from the other eBay, the Classifieds Group, which means we have even more and more marketplaces now, more and more teams, and you will see later how this is a challenging scenario for a data catalog, if you are not guessing already. If we look at the world map, this is more of like this. I'm, as you mentioned, I'm in Barcelona right now. So just in the middle of the screen, as you can see. So this data catalog thing, what's all of this about? Why do we need a data catalog anymore? Or anyway, right? This is more or less our product. We call it the data highway. And it's basically a composite of many managed Kafkas that we manage for our clients, for our tenants, which are all these marketplaces and some central operation groups. And we also have data sets in data lakes and something we call FMDQ, which is filter, map, dispatch, and quality, which is how we move data around from one Kafka to the other, from one Kafka to the data lake, or from one Kafka to anywhere that you need it, actually. Then we have an inventory of assets that we need to maintain all of this running. And then we have something that is called DataHub. But this is not your DataHub. this was before DataHub was public. We used this name, we decided on this. It was a cool one, and suddenly someone decided to copy it. So let's call it, for the purpose of this chat, because it's already confusing inside Adevinta. So the governance UI, okay? Let's call it governance UI. Okay, what do we use the data inventory for, like the one we have today? So we need to self-serve manage the authentication or the authorization in datasets. So we cannot control the authorization for all these datasets that we own from different marketplaces. The marketplaces need to give access to this because we are like 5 people or 10 people in the team, and there are many datasets, as you will see. So we have done this self-serve, custom made, and this means that people need to control this. To control this, we need a list of datasets. We also need to comply with regulations. If anyone is in Europe, you will know GDPR. So yes, we need to delete private data. We need to extract private data. And for this, we need to have an inventory of datasets. The inventory of datasets is actually part of the law. And then to manage of the Kafka topics we have, if anyone is working with Kafka, as you are, you will see that the topics themselves, they don't have any metadata. You cannot store this metadata in Kafka. You need to store it somewhere else, like LinkedIn data, for example. And at the moment, we are doing this in Atlas, and I will talk about this a little bit later. And then another thing that happens is we need to link like one asset with one Athena table, for example. To give permissions, we give it to the underlying data set. A little bit of lineage here, we need to manage this. For this, an inventory is good enough. So I can relax, sit back, and enjoy my coffee. The problem is that we have users, and these users are quite demanding, right? So they want lineage, they want documentation, they want glossary, they want dashboards, they want full text search, and all this fancy stuff. Like I want health scores on the dataset, and I want community saying this is a good dataset, this is a bad dataset. Like, are you serious? Like, this is like my kids coming here and asking me to play with them. Like, I don't have time for this. But actually, I have. That's part of my job. But it's a little bit, it's a little bit overwhelming. So we said, cool. Yes. But what happens is we have, a lot of data and a lot of flows of data moving around. So an inventory is not good enough anymore. We need to change, and there is a tool for this, which is called a data catalog, right? So which tools are out there that can fit this and are better designed for this purpose? And LinkedIn DataHub is one of these, like for DataHub for now on. So we said we need a re-architecture, right? And on top of this, remember we have many tenants, many marketplaces, and someone say, hey, we need to do a global data catalog, and we need to do it like data mesh. I don't know if you're doing data mesh, but everyone talks about data mesh. No one knows how to do data mesh, but everyone talks about data mesh, right? So we have now suddenly Leboncoin, Subito, the Spanish marketplaces, Belarus, Austria, all of them coming. And probably soon we will have also the eBay parts in Canada, South Africa coming also to say, hey, take my data, I want it to be in a data catalog. So in order to tackle this problem, we said, okay, let's divide and conquer. And we split it, what is the LinkedIn DataHub or the DataHub architecture, into 3 batch. On one side, we have the ingestion part, which is how do we put data or metadata and lineage inside the tool. On the other one is like, how do we manage this infrastructure so it scales, so it grows, so it's stable, so it can be accessed from different places. And the third part, which is the one in the API and the integrations part, which is the acting part, like how can we make whatever happens in DataHub have a side effect or have some kind of effects and integrate with the rest of our tooling, because we have also, as you might have guessed, other tools apart from the data catalog. So we said, okay, let's do these POCs, right? We did 3 with different teams did other POCs, and in my team we did the one with LinkedIn DataHub for our purpose, for our product, sorry. And we said, okay, let's start with some research on which alternatives are in the market. So we look at a couple of them. we already knew Atlas, we already knew our own. We have some people looking at third parties, and we were quite interested already. We were quite biased towards the LinkedIn DataHub, so I have to say, like, we already liked it from the media and from the blog post and so on. So we said, okay, let's give it a try, and we find it in June that was really easy just to display data from these off-the-shelf connectors, right? So like having Redshift data, having Athena data, it was like a couple of hours literally to see it in localhost, and it's like, seriously, like this is too easy. And another thing that we discovered also quite early was like the infrastructure maintenance cost of it compared to the one from Atlas that we have already for Kafka. It was much more light, right? So it's like, okay, this is easier to operate. So from July to September, we have been working on this. Okay, we divided the squad into two, on the connectors part and on the infrastructure or serving part. On the connectors, we have kind of in production 4 off-the-shelf connectors. I will explain which ones. We made one custom connector. We made 2, but one is more mature. We have the production, the infrastructure production ready with a little bit of bad, but we have it production ready. And we did an MVP of the UI that I will explain later what's the problem with the UI. So now what we will do until the end of the year is try to get more data origins, as we call, with external teams. So set up more connections from different marketplaces, so more more Redshifts, more Athenas, more Glues, maybe a Snowflake, maybe something else, and do some kind of user research. Like, do you like this? Do you find it useful? Is it easy to make the connectors? From the tenant perspective, like they don't own the infrastructure, they just need to send the data and take value on the other side of the pipeline. On the ingestion part, we very quickly we will put a Redshift off the shelf, and thanks to the big team, which give us the credentials to this because we don't own Redshift, we could put also Athena. We use the Glue connector for Athena because it's more generic. But if anyone has a different opinion, please contact me in Slack and tell me the pluses and deltas, because I think Glue is better, but maybe you think differently. For Kafka, we run into a couple of challenges. Like, we have the same topic in Pre and Pro, and if you just put the topic name, then there are some collisions there that we found in the browse path. And what we have decided already is that we will replace the Atlas solution regardless of the result of the POC, which is still running. We need to validate with users. So we will change it. We will change Atlas for LinkedIn DataHub because it's, again, easier to maintain on the infra side. We tested Okta because we need the list of users. And the next, we are already talking with people about more Redshift, maybe Hive, maybe Snowflake, maybe BigQuery, and see who is in for testing. So we depend a little bit on our colleagues. And the click is not clicking, so yeah. And the custom connectors, again, I said we have an inventory of datasets. We need it to maintain access and authentication. So we need to implement and show this in the catalog. This is key for us. But because it's a custom solution, we need to do a custom connector. And it happens the same with this filter map dispatch and quality lineage, which, because it's custom built, it needs a custom connector. We don't expect you to build a connector for ourselves, no worries. On the serving part, okay, we deploy this in Kubernetes, and again, kudos to the common platform team. We have the connectors orchestrated with Helm charts, if I'm not wrong. We are finalizing the monitoring and the alerting of these things, as you also are improving this, as you mentioned. The good thing that we found that I like, or that we like, is the metadata ingestion on top of Kafka, because it gives this possibility of getting to the past of, okay, reset my consumer offset and reset all this data. And if the ingesting part is down for a while, then it can catch up later. So that's a good architectural pattern we have tried in the past, and that happily surprised us. So now the challenge will be to define how to make these multi-tenants. So one tenant doesn't break the other tenant's metadata, right? It's a couple of a little bit of an interesting challenge to have. And the other one is the MVP, the UI. So I explained we did an MVP of the UI, which means like the research that we have done internally in the company, it says we already have too many UIs. So we have if we have the data catalog in a different part from the governance tool or from the machine learning platform or from the experimentation platform, it's already a bigger mess. So we are trying to consolidate all these tools into a more centralized UI. So don't make the problem worse by adding now a data catalog. And this is a challenge, and this is a pity, because the challenge is how to do something as good as the DataHub UI internally without rewriting all the components, right? So this is an interesting challenge. If you have a solution, please send it to us. But this is more or less what we are doing. And the reason is because we have these actionable things that we need to do in the data catalog. So for example, we can delete a data set which actually deletes the data set and the information of the data set, or we can archive it, or we can add permissions, we can edit the metadata and it stores it in the source of truth. So there are a couple of things here. We have custom dashboards in Data.com with statistics on which people, which tenants are sending data to this data set. So there are a couple of things here that we cannot replace, and that's why we are not using the UI for the moment, or we are not using the UI fully, but we might use, I don't know how, the React components as much as we can, for example. The GraphQL queries, for example, are very useful to us, yes, just for record. And then the actionable part. So we will investigate how to do this with our own things, with our own Kafka, with our own S3 data sets, with the PII information we manage. With the rest of the tenants, that will need to wait at least until next year, probably a little bit more, because we are not there yet. We are lacking governance and agreements to do so. And very quickly, because I'm not checking the time, Maggie, don't look at me. Some findings so far in these 4 months, we have actually been working here. Is like kudos to the community. There were a couple of names on that slide of contributors that you mentioned. So we are super happy of being able to contribute. There is this 1,302 people, probably there are more now. The atmosphere in Slack is super good, response is great. There are a couple of hours of delay, but that's normal because of the, you are sleeping when we are working, so that's okay. And yeah, the development speed, new features are super fast, are very good. Bugs are fixed very quickly, so super happy there. The other one is the architecture that matches what we want, so that's okay. Simply, right? And then the main problem here, which we already know, is independent from the tool. So our inventory, LinkedIn, DataHub, custom-made solution, commercial solution, the problem is the same. Like, how do you fix multi-tenancy? How do you do it like the data mesh? What do you do when there is no metadata, no governance, and with the data quality? So I describe this as, we can do the best tooling ever, but if you put something in, you will get something out, right? So sorry, but it's what it is. And any tool cannot solve it. And if you make a tool that solves this, then you actually can charge a lot for this thing. So summary, the future is quite promising. I'm quite convinced that we will use LinkedIn DataHub for a while. Even beyond the POC, we might end up using this for ourselves, for the things that are under our own control. For the group level global catalog, we need to see, because that decision doesn't depend on us. But at least for the moment and for 2022, I see a quite promising future, and I see LinkedIn DataHub being used quite a lot. And I think that's it, right? Yep. I don't know if there's time for questions on it. You tell me.
Yeah, are there any questions? You can also throw the questions in the chat and we can take them async. Iker, thank you so much. This is awesome.
Yeah, thank you. Let me try to unmute myself.
All right. We have a couple more things to get through. So Shirshanka is going to talk us through some recent improvements to our Looker connection, and then I'll do a quick run through of that.
All right, Iker, that was great, and loved the problems that you called out around both being able to represent multiple tenants well inside the catalog. I think that's actually something that's top of mind for us as well. So we are going to be modeling domains way better, and so you should be able to create multiple namespace metadata graphs very soon. And in terms of extensibility of the UI and being able to customize it, that also is very top of mind for us. So I think it's a very right time to get involved in that effort as well. There's quite a few people in the community who have that requirement, including the LinkedIn team, who runs a very complex version of DataHub inside. So it's a great time to actually collaborate. All right, moving on. The Looker connector has had quite a bit of improvements. Some of it might be a bit disruptive, so it's important to kind of pay attention to this. Quick intro to Looker itself. Looker is a complex beast. It is an ETL tool as well as a BI tool and everything in between, which is the slippery slope that all BI tools fall into, right? So here are the concepts. Looker connects to your database, or it could be multiple databases through something called a connection. You typically host your Looker stuff in a project, and a project typically is one-for-one with a GitHub repository where all the Looker files are also checked into in the back. Looker is amazing at this stuff. What's in a project? Well, there are model files. That's kind of like a namespace. And model files include view files. So you can have views inside a model. Think of it like views in a database or views in a schema, I guess. And they also include other files like your dashboard files and things like that. So these are kind of the file-oriented view of what a Looker project looks like. Let's talk concepts. You've got a database, you've got views, then you've got explorers, which actually expose those views into your charts and dashboards ecosystem. So from the right to left, you've got dashboards, which contain charts, which are sitting on top of explorers, which are pulling in data from views, and views are pulling in data from databases. So that's really the ecosystem. And the previous connector, before we made changes, had a few problems. One, we have two connectors, actually, two sources. One that goes after just the charts and the dashboards, called the Looker connector, and one that just parses the files, which are in the Git repo, called the LookML connector. And the two of them were actually non-overlapping. The Looker connector went after dashboards and charts and tried to guess lineage to views. And the LookML connector would get the views and tried to get lineage from the database. It was almost correct, but there were some small glitches in how they were working. Firstly, views were being named as global names, which looks great until it breaks, because you might have the same named view in a different project, and then very soon you've got name collisions happening on views. There were some challenges with correctly resolving partially specified table names in view definitions. When you write SQL, you can write the full definition like a.b.c database.schema.table, or you can just say table name, and Looker kind of does defaults. It did not understand explorers at all. So it was hoping to get to views from the charts, and it was making mistakes. It was also not pulling in ownership. So you'd have all these charts and dashboards in DataHub, but not really know who owns it. And that was kind of like a missed opportunity. And finally, if you have really complicated LookML files with lots of nested includes and things like that, the parser would just not be able to get to all the views correctly. So these were the problems. And next slide. We've made improvements to them. It's available in the latest version, 08.14.2. And we're actually making quick improvements to it even now as we're getting feedback. So there might be a 0.3 and a 0.4 coming out soon. But a few decisions that we made that you can control is how views should be named. So we decided to name them based on the project name. So this is the project under which the views live. This is typically your GitHub project name. And we're naming views as project name.views.viewName. This is actually a configuration parameter, so you can even change it. Go read the docs. We also have better specification for these DB connections, because those DB connections are actually maintained on the Looker side. And we now support resolving those database connections through the API as well, but you can also specify them offline. And we're also extracting explorers and owners. On the Looker side, there are no really required changes for Looker ingestion, But the lookml config now supports API credentials. And if you do that, it will do a lot of resolution on its own and you don't have to provide it so much help. And if you're not using the API, it requires the project name. So net, it's all good. One big caveat, if you're upgrading to the latest connector from a previous connector and you've got data or metadata ingested from the past, you will see views get named differently and your old views are going to stay unless you nuke them. So be aware that that could happen. So you want to roll back that ingestion if you want to remove those views. Or if you really don't want to touch your view naming, you can actually change that config parameter to name views the same old way that they were being named. The docs actually go into that in a lot of detail. So thanks for listening. Please play around with the new Looker connector and give us feedback. We're still making quite a few improvements. And we can actually show just a brief demo of what that looks like on DataHub demo, because we've done some ingestion already and put it up there.
Yeah, so to kind of take this for a test run, this is our own Looker instance. And I took the lead on ingesting basically the metadata flow from DataHub. So how the metadata is actually structured. So let's see here. For example, we have data set property, or sorry, we have, where did my thing go? Oh, there we go. Data set properties. So this is where Shirshanka is talking about the concept of a view. A view is then pulled into an explorer. And this explorer lives within this model, right? So these are just like very basic Looker notions. So within the explorer, we now see, like in the browse experience, we now see a data set exploring here and allows folks to add fields and build out visualizations, etc. So by leveraging that, I built out a very meta dashboard, because of course we love metadata here. And I wanted to get a sense of how many dashboards or how many data sets or how many assets or entities within our DataHub demo instance are missing descriptions, right? So getting a sense of kind of the health of our metadata there. So we have it broken down by environment, by our platform type, by the schema, and then just the data sets as well. And then down here, we have a beautiful sand key. I'm a sucker for a sand key chart that shows you the flow of the data sets between all of those different environments. And ultimately, this terminal node is how many have descriptions on here. So cool, now we have this dashboard. So if we go into our DataHub demo and we look for DataHub health, we'll now see this dashboard in here. And this is owned by me, that's great. Within this, we have these various charts, which are also owned by me, and that's also great. And then if we wanted to look at the lineage of it, we can start to look at, we have our dashboard, our DataHub health dashboard here. Our chart is here. This is built off of a lookml data set, which is actually, this is one of our, or sorry, this is now what Shirshanka was saying. We're inserting in the namespace of it being an explorer. This explorer is built off of a handful of view files here. So, oops, no, zoom in. So now user basic info, for example, we have, we're qualifying that as a view within Looker that sits on top of a snowflake table, which is ingested using an Airflow job, et cetera, et cetera. So we start to see the full lineage of data transformation then presented. I think there was one other thing. Oh, the other thing is when in the actual browse path, if you're looking at Looker data sets, we used to just kind of lump all of these together as views. We're now actually separating out these entities between explorers and views. So we're getting it closer to, we're mimicking the same kind of like namespace and structure of Looker. So it's more intuitive, and you don't have to kind of do the mental gymnastics of, is it a data set, is a view, Looker calls it this, Looker calls it that. We're now treating it, with the Looker kind of syntax there. So,
another sneak announcement that things that'll come to the UI very soon is you'll start seeing not only Right now, when you look at the search previews, it says Looker dataset. So that'll start having to say Looker view. It'll start saying Looker view and Looker explore. So it'll make it even more clear whether you're interacting with a view or an explorer. Awesome. I know we're out of time, so thank you, everyone. And the roadmap is looking great. We have for the next month, one of the things that we are going to be working on is column level lineage. It's been cooking. We've got a bunch of stuff already working out internally, and we'll start seeing some of that getting released over the next month. So thank you, everyone. If there are any burning questions, we can of course take them now, but Slack is there. We've got amazing channels now, and there's a lot of chatter also going on.
Thank you all. Have a wonderful weekend. Iker, enjoy your beer.
Thank you.
Talk to you all soon.